Hello students, see this question now. Box of mass 14 m, okay, with smooth base sliding on an inclined plane of inclination shown under the influence of force F. So we have a box over here, okay, it's lying on an inclined plane of inclination 37 degree. A force F is being applied. A string of mass m, length L is attached at A. So here we have a string, okay. The box is released from rest and a transverse pulse is produced at the other end B. Okay, we are releasing the system on an inclined plane, okay, under the effect of F, and we are creating a pulse on the end B. So we have to mark the options regarding the pulse. Now the first two options, what do they say? If F equal to 0, the pulse will remain stationary. If F equal to 0, the pulse will not reach to end A. Now see, the interesting thing is these two options can be solved directly without any calculation if we have a good idea about how physics works. Okay, so let's try to understand that. If F equal to 0 means what? You are not applying any force, then the box and the rope are falling along the incline under the effect of gravity. They are naturally falling, okay, without any force. Okay, a gravitational force is there, but under the effect of gravity they are falling naturally. So it's like a free fall motion. Okay, it's like a free fall motion. Okay, so in case of free fall, if I drop a rod or if I drop a, let's say, rope, and it is under free fall, then there will be no tension anywhere inside the rope. Okay, that means if F equal to 0 along the incline, they are falling similar to free fall, and therefore the rope has no tension. Okay, in these two cases, rope, so the rope has tension 0 throughout the length. Okay, and therefore the speed will be 0. Speed of wave pulse on the rope will be 0. Okay, but the speed is 0 with respect to rope, with respect to the box. Okay, so first of all, let's look at the option B. If F equal to 0, the pulse will not reach end A. So yes, relative to the rope, the velocity is 0, so the pulse cannot travel. Simple. Okay, so option B will be correct. What about option A? If F equal to 0, the pulse will remain stationary. Velocity is 0, but this velocity is with respect to rope. Velocity of pulse is 0 with respect to rope. So is the rope stationary? No, the rope will be accelerating downwards on the incline. Okay, so therefore the pulse will also move along with the rope. So with respect to ground, pulse is not stationary. With respect to rope, pulse is stationary. Does this option mention anything? No. So we assume option A is with respect to ground, and therefore option A will be wrong. Okay, now we have to calculate for C and D. So for that we need to calculate the values first. Okay, so let's say the system has acceleration A. Alright, so how will you calculate A? So we have force F acting over here, and we also have force, how much? Total mass. Box has mass 14m and the rope has mass m. So total mass will be 15m into g into sine 37. Okay, so this is the force component due to gravity. All right, 1 second. Yeah, so what is the acceleration? So total force will be 15 mg sine 37 plus F, that will be equal to 15 m into A. So I get A will be equal to g sine 37 plus F by 15 m. Okay, alright, so this is the acceleration of the system. Now let's look at the rope and find tension inside it. So this is your rope, okay, and A and B. Now I cut the rope with an imaginary cross section, okay, over here at distance x from end B. Then for this section, what is the tension over here? Tension at this point, tension at this cross section will be how much? Very easy to calculate. Okay, So tension plus, what is the mass of this section? Mass of this section will be total mass of the rope divided by total length of the rope into length of this section, which is x, okay, times g sine 37, okay, mxg by L sine 37. This is the force acting on the section of the rope. These two forces are acting on it. So this will be equal to total mass of the section mx by L into A. Mass of this section is mx by L. Acceleration of this section will be acceleration of the system A. Okay. So I get tension to be equal to mx by L A minus g sine 37. Okay. Now from this equation, what is A minus g sine 37 equal to? So tension will be equal to mx by L. This will be replaced by F by 15m. Okay. So this will be equal to, okay, yeah, we could leave it like that. Alright. Now, velocity of the wave pulse will be how much? When a wave pulse is crossing the rope from this point, okay, it will have some velocity v with respect to the rope. Velocity v is with respect to rope. So velocity v will be how much? That will be equal to under root of t by mu. Mu is the linear mass density. So under root of t divided by m by L. And from here, what do we get this to be equal to? This will be equal to root of fx by 15m. Okay, clear? So you could see from here also, if f will be 0, velocity will be 0 with respect to rope. That's what I was discussing for the first two options. Okay, v equal to 0 when f equal to 0. Correct? Now we have to check option C and D. Alright, we will do that. First of all, let's find the acceleration of pulse with respect to rope. So let's just call it A relative. So that will be how much? V dv by dx. The pulse is covering distance x with time t. Okay, so acceleration will be v dv by dx. So we have to differentiate this. Okay, so v will be how much? Root fx by 15m. And dv by dx will be how much? You differentiate this. So you get root f by 15m times 1 by 2 root x. So A relative will be f by 30m. Okay. Now, time for pulse to go from point B to point A will be how much? Total distance covered will be L. Okay. So L will be equal to half A relative t square. So T will be root 2 L by A relative. So that will be root 60 ml by f. Okay. Now just put the value. So f equal to 9 mg. When you put f equal to 9 mg, option C. So T will be under root of 60 ml by 9 mg. M will cancel out. Okay. 3 times 3 9 and 3 times 20 will be 60. So this will be equal to 20 will be 4 times 5. So 4 will get out of the square root, 5L by 3G. Okay. That's what is given in the option. So option C is correct and therefore option D will be automatically wrong. Clear?